Hey guys, so I've got this new electric motor mounted on my e-bike. I call this the e-Shelby. It's just an old AMF Shelby that I converted to an electric bike, and I used cedar paneling and stuff like this. But this is a Skilsaw motor that I rewired with my new invention to make electric motors more powerful and to convert them to run on AC to run on DC instead. Just because the DC power, it has better starting torque. It's continuous power. It's not constantly changing direction, unless it's pulsing, but it's pulsing. It's pulsing in one direction, so it doesn't pulse in the other direction particularly, except for the counter EMF. But that's a counter collapse of the magnetic field. It's not necessarily a counter motive force, because there are machines that can eliminate most of this counter motive force. So anyways, that's what my invention is supposed to do, and I've had a lot of success in doing this, simply because I understand what I have to do to avoid these counter motive forces. There's still going to be electric induction and there's still going to be magnetic induction, but the two forces are actually different things. The electric field goes out in all directions basically to infinity, where the magnetic field is a warping of the field, and it's very localized, closer. It gets stronger the closer you get. Very dramatically difference in the structure of the flux around these different types of potentials. That's all we can really call it, potentials, if you believe in aether science. So anyways, without further ado, this is a homemade motor. Like I said, this was a Skilsaw electric motor, and I put my Waterwheel field down in there, and these are some homemade brushes and the plywood. Let's see, I'm going to start on the starting coil first. It's probably going to have a lot of power to it. Yeah, so it's wanting to keep speeding up too. That's another thing, when you hit the resonant sweet spot, a series DC motor will just keep accelerating. Now, I didn't believe this because we were taught, in electronics and just ordinary physics, that well, you have to put more and more current to get the motor to go faster and faster. Or you have to put more and more voltage. That's another thing you can do. But also, they're leaving a lot of things out. Like, you can reduce the drag and the counter motive forces. You can reduce the resistance and increase the field strength. Without creating a change in total inductance, the total impedance, I should say. So when you change these different variables, or even with frequency, if you have AC motors, if you hit the resonant sweet spot on that, it can drop. You can have a significant drop in the resistance. Some people have talked about these particular generators actually will seem to speed up under load. I've seen a phenomenon where actual physical pressure on the commutator makes the motor go faster. Now, how that shouldn't even affect conductivity or resistance or anything. Physical pressure, except for the piezoelectric effect, I've never really seen too many pressure. I'm thinking maybe nitinol alloys, something like this, where it's changes based on temperature. Resistance always changes on temperature. We use thermocouples and we use thermoresistors to compensate for high gain, like instrument amps for medical purposes and things like this. That was something I used to do. Was I designed really high gain amplifiers that could have been used for medical purposes, and like sensors for paraplegics and things. There's so many things that can be done with science that what do you do? Someone has to be willing to do it and pay for you to do it. If no one wants to hire you to do it and pay you right, then what's the point in even doing it? If it's not going to help people. That was the thing. I always said, well, I was going to build robots to help like people who are crippled, stuff like that. Then I got into doing computers. Never could make any money with computers, and they came out with that. With Windows came out with multitasking, so I quit working on computers, worked on virtual reality, invented all that. It's been 20 years, and it still hasn't really taken off. But there's a lot of philosophical and probably just there's even going to be legal issues eventually at some point. Because whoever controls that virtual reality in the fake TV controls what everybody thinks, and it may not be what's real and what's true. Joe Newman was a real man and had free energy machines, and his information was suppressed. And every other person who's invented what I've invented here, or something similar, they haven't invented what I've got here, but everyone that's done something similar, I should say, where they dramatically increase the efficiency, or they make something that works really, really well, and you know, no one seems to know why. Or like that mystery I said, you know, with the adding pressure makes it go faster. No, that should add load and friction. It should break a brake. When you put a brake on a drum, it should slow the drum down, not make it go faster. So all these sort of things. And I've seen evidence of invisible plasma. Like you can sort of see the outline of it. Like there's a boundary layer, and then you can see through the inside of it, you know. And I've seen videos of UFOs that were like this. They had this sort of weird boundary layer. Then you can see inside the nucleus of the plasma, but no one knows what these UFOs really are or how they work, and no one really understands the electricity, but they'll certainly suppress it. So why or how that works, I don't know, but you seem like everyone I try to make friends with and show this motor to or explain it to, then they just end up hating me and want to attack me later on, you know. I mean, I was fortunate. I've actually made some better friends online than I have just like here locally. Well, except for my next door neighbor Bruce and Leota, they're really great people. They've helped me so much, you know. My friend Michelle helps from time to time, but you know, there's a nice girl at the store that's just somebody to talk to. But other than that, all my friends are online, and I did get to meet Hiram Babineau in real life as a good guy. Shout out Hiram. We're gonna play chess later tonight. So, anyways. Let's run this again. I'm going to run it on I'm going to run it on the overdrive coil for a second. Let's see, which is right here. See, that one actually seems to draw more current, and it got hot right there. I'm going to do this one. See, that one was glowing like a nuclear radiator. It wasn't hot at all. That one didn't. I'm able to hold my fingers right on the connection. Ooh, something's burning down in there though. I see smoke coming out. Interesting. Well, that's probably just the adjusted neutral plane. That's just the brush positions causing the arcing at the commutator. I can fix that, so that's not a big deal. But it's still drawing too much current. I'll probably just take this field pole out and totally change that out. Oh, that's nice. It's just sort of warm. It's not super hot. That must have been one of the brushes that was. Yeah, that brush is smoking hot. That just has way too much friction. But like I said, the motor started going faster and more powerful with that brush on. Let's see. And that's actually a lower impedance coil. It didn't seem to be drawing as much current though. Even though it's a lower impedance coil, the effect is to oppose the current. Where's the wire I'm trying to grab? Here, this one. Yeah, run that again. Whoa, yeah, something's throwing sparks out of there now. Probably hitting some steel. Alright, well, that was fun. We had some nice sparks, and we know it's working, but definitely have some bugs to work out. Anyways, just want to say thanks for watching.